Our last presenter is Fred Rothauge with Hydro Resources. Fred has been around a very long time in our industry.
I'm not that old.
No, he's not. He started really young. But he is a past board member of our Utah Groundwater Association and is very involved in Utah, both drilling and in helping the industry out. And he's also very much involved in the National Groundwater Association in leadership and volunteering and helping out on boards and whatnot there, which he's currently doing. And this year he happens to be the NGWA McElhaney Distinguished Lecturer. So he's been going all over the country giving this lecture to groups like this of drillers and pump installers and those involved in our industry. So this is something that is, it's a national lecture and it's very interesting, and he's going to be talking about making sure we're doing a good thing when we're drilling wells and making sure that they're a value and an asset and that they are long-term, that situation. So I'll turn the time over to Fred and we'll go from there.
Thank you, Jim. A little bit about my past. I was raised in Oregon on a little farm. Didn't know much about water, but we depended on water, but water well drilling wasn't anything that I knew anything about. Either was oil and gas. I went to Oregon State, or I actually went to Treasure Valley Community College and studied range and forest technology over there. Then I went to Oregon State and got me a teaching degree to teach forestry. And I did that for a couple of years in Chiloquin, which is just north of Klamath Falls. And the timber industry died. So when it died, it's like, what am I going to do? So a friend of mine was working the oil field in Colorado, so I went ahead. Actually, he was in Wyoming, but I went ahead and went up to the rig, got a job, worked there for a little bit, and said, hey, I'm going to get part of this oil field. But lo and behold, I got into it as a drilling fluids engineer, but I found out that I liked the water side better than I did the oil and gas side. There was a lot more for us to think about when we're drilling a water well than an oil well. Because when you drill an oil well, what do? You frack past all your damage, correct? If you have damage when you're drilling that, I can frack past it, I can still produce the oil. But in our industry, if we have borehole damage, we are shutting off that water flow back into the well because we're not actually pumping it with the pressures that they have in the oil field. So I started looking at the water side and trying to figure out what can I do to improve it. I had a drilling fluids company that I was working for. They went busted after 2 years. And that was back in 1983 when they went belly up. But if we think about why, interest rates back then was really high. It was about 20%. So we think interest rates today at 7 is high because we got used to that 2%. Well, interest rates back then was 20. But I decided when they went belly up that I was going to start my own business. So I started a drilling fluids company. And actually, I never got it really started until 1984. I went with a partner before that, and I saw we were going to go belly up if I stayed with him. So in 1984, I pulled this, started my own company. And I specialized on the water side more than I did oil and gas. I had a big interest there. I sold my business in 2006 to Hydro Resources, who was a water company, or I shouldn't say a water company, but a water well drilling contractor. They were buying water well drilling contractors at the time, trying to become more of a conglomerate. And they decided they needed to have a mud company. And I was doing the drilling fluids for several of their businesses at the time. So they said, we want you to be part of our business. We see a value in what you're doing. So they ended up buying me in 2006. Lo and behold, 5-year contract ran out. They thought I was going to be gone, but I'm still here. I still work for Hydro. As Jim said, I'm on the board for the National Groundwater Association. I'm also on the board for the Mountain States Groundwater Association, the American Groundwater Trust, and the Groundwater Foundation. So believe me, I want to see our water world evolve. Once we run out of water, we run out of life. We've got to take care of our water. I want to see a show of hands. How many well diggers do we have in the room? How many well drillers do we have in the room? Okay, we got less well drillers than we got well diggers. That's kind of a shame. How many water well or groundwater well professionals do we have in the room? Come on, everybody, raise your hand. If you're in this room, you're a groundwater professional. Back in the day when we used a shovel to dig a well, we were well diggers. Okay, when we progressed to use something that went around and around and around, then we became a well driller. But today, we need to think of ourselves at a higher standard than being a well digger or a well driller. Because even if you're in the drilling business, you are a groundwater professional. You think about your job. You know, is your job as important as the doctor that looks at you? Hell yes, it is. Your job is just as important as the doctor's. Without you, there is no life. If we can't go ahead and supply water, safe drinking water to our users, there is no life. So then the doctor has no use. Why do we need a doctor if we don't have life? So I like to think of it that way. Now, the doctor doesn't, because he's going to tell you that he's the most important thing there is other than the lawyer, right? So today I'm going to give you the McElhaney Lecture series that I've been given all over the country this year. I think this is my 19th talk so far this year, providing this McElhaney Lecture. And what the McElhaney Lecture is, it's a lecture series that was designed to foster professional excellence in the water well technology. The National Groundwater Association sponsors it today. It was the National Groundwater Research and Educational facility or program that actually started it. But it's in honor of William A. McElhaney. He was the first president of the National Groundwater Association in 1948. He was the president. He was the one that started the association. So this is in his honor. My talk, are we creating long-term groundwater assets, or are we just installing wells? So again, show your hand if you're a groundwater professional. Show your hand if you're ones that are installing the wells. Okay, you're the professionals that are installing the wells. Everybody else is involved in the water industry, and you have just as important of a role, and you're going to find out through my talk today. So when we look at the water well, it can be defined as an asset, correct? The water well is an asset. But the aquifer it produces from is also an asset. Without the well, we can't get the water out of the ground, so the water has less value if we can't bring it out of the ground. So the groundwater is an asset, and the well is an asset. Groundwater, we look at, it's there, a lot of people think, indefinitely. Wrong. It's not. But as long as there's water in the ground, we have groundwater. The well has a shorter life cycle than the groundwater in most cases, unless you're in the Ogallala. Then you can say the groundwater's probably got less of a life cycle than the well. But everybody's starting to see value in managing their groundwater. They used to not really manage it. They used to mine it. Today we're starting to try to manage it more than we are being a mining industry, mining that groundwater, pulling it out faster than we're putting it back in. We're starting to look at that because we know that once we run out of it, the communities will dry up. We have to maintain a long-term value to our constituents and for survival. So to be a long-term groundwater asset, that involves much more than just installing a well, though. There's a lot of things that go into making that groundwater a long-term and the well a long-term value. One of them is the water quality. If we don't have good water quality, is the groundwater an asset? It might be there, but if it's not taken care of and the quality's bad, can we consider that a long-term asset? The answer is no. What's that?
I say dirty, it's wet.
Yeah, it's wet, but it's not much of an asset. But a lot of times, it's things that we do that make that less valuable. If we contaminate that aquifer, it's less valuable than it used to be. So we need to make sure that, if it's naturally occurring, that's one thing we have to deal with. But we want to make sure that we don't degrade the value of that asset. Also, we got to look at the water quality or quantity. Is it abundantly sustainable? Is it replenished every time it rains? Or are we in a confined aquifer and are we lowering that water table? Are we using that water faster than we're putting it back in? Most of the country, most of the world actually, not just the country, has a declining water level. So we're pulling the water out faster than we're putting it back in to our deeper aquifers. We have to look at whose water is it. A lot of times in Texas, we think the water under our feet, and I'm living in Texas now, we think the water under our feet is our water. But really, it's everybody's water. They don't control it very well unless you're in a management area in Texas. But it's everybody's water. And if I take more water out than I should, then I'm degrading the water quality and the quantity for my neighbors. But everything that we do with the groundwater hinges around the water well. Just about everything we do, either the water well or the injection well or surface contamination or something, but most of it's the water well. So what makes a water well a long-term asset versus just the well? You drillers, right? You make it a long-term asset. You water well professionals make it a long-term asset, right? I like to say that it has to have usefulness that has a long-term value or a long lifespan. And that we should make every well like a Cadillac. Okay? Why would we make a well lesser than optimal? We want to make it like a Cadillac. We don't want to make it like the Yugo. The Yugo was the worst car ever made, some people think. I don't know if it was or not because I don't know every car that was made, but did you have a Yugo?
No, I just wondered why it was worse. I never had one either.
Well, I don't know if you can even find a Yugo distributor in the United States, or if you had one, if you could get it worked on in the United States very well, because there wasn't very many of them sold, but you can't find one on the road hardly today. I know there was a few people that's got one, and the reason I know is because I gave this presentation in Colorado. It was my second presentation, and a guy stood up and he says, "My son drives a Yugo." I'm like, oh, crap. But then he sent me a picture of it. That's his son's Yugo. Okay?
He needs to take better care of it.
No, he did take good care of it. It's still running. Okay?
It still looks like
Yes, the Yugo cost less to buy, but what did it cost him to drive it? It wasn't an expensive car. It was very inexpensive. It was almost like a throwaway type car, kind of like the Chevette or the Mustang. Not the Mustang, take back the... Huh? Edsel, but there was another one. Ford had one. Pinto. The Pinto, yeah, the Pinto, yeah. It was kind of like them. They didn't. You don't see them today.
For 20 years.
Yeah.
Yeah, it was great.
Yeah. So, yeah, he had one. You can see almost everything on it's been fixed. I talked to another guy. He says, "Yeah, we had one," and he said,
it's readily available, obviously, the junkyard.
when he closed the door, the handle came off. The first time, or I shouldn't say the first time, but right after he got it, closed the door and the handle came off in his hand. So they were a cheap-made car. Well, you know what? There's a lot of cheap-made wells out there too. We have to take pride in what we do. How many of you can say that you're proud of every well that you drilled or constructed? Every well. Okay, I can't say that because there's wells that I feel like we've compromised because of problems associated. You're drilling the well and something goes wrong. So I can't be proud of the well. Yeah, we got it built. We supplied the water to the customer. But I can't say I'm proud of every well that we drilled. Of course, we drill thousands of wells a year. But again, I can't say that I'm proud of every well because there's things that happen when we're drilling. No two wells are the same. To be a long-term asset, does it operate efficiently? Well, Did the Yugo operate efficiently? Or did he have to do maintenance on it more regular than he do a Cadillac? Does it require frequent service? Does your well require frequent service? You got it installed. Does somebody have to go out there every couple of years and do something to it? Maybe it's plugging up. Maybe the pump has issues. Or when you walk away, is it good for 5 or 10 years without anybody looking at it? I know there's a lot of owners, well owners, that don't even know where their well is because they operate efficiently. We had a call one day where somebody wanted us to come out and look at their well because they had a problem with it. We went out, looked, couldn't find the well. Come to find out, they were on city water. Okay? And they were working on the system, and that's why their well wasn't working. But they thought they had well water. Normally, we see it the other way around. People think they're on city water, and they end up being on well water, and they're out of water. But this was the opposite. Does it meet the future needs of the owners? You know, does your well meet the owner's needs? The owner, when he specified he wanted a well drill, he probably told you why he wanted it, what it was going to be used for and everything. So you build it to meet his needs. But then, now, he's got to use that water to supply his customers. Does it meet the customer's needs? So again, does it have a long-term asset value to the user, not just the owner? Was the well constructed using the best design, the best drilling fluids program, the best known development practices, the best construction materials that you could use, the most efficient and best pumping equipment available? Did you use all that when you built your well, or when you planned to construct your wells? Or was it constructed using a lower cost design because you're trying to save your customer money? We do that often, don't we? With questionable drilling fluids program, or maybe no drilling fluids program at all. Oh yeah, I was a drilling fluids engineer, so I look at that all the time. What are you doing with your drilling fluids program? Is it a good one, or are we plugging up the formation? Did you use less effective development practices, or are you just using one because that's the tool that you have? Is it the right tool for the job? Are you looking at cheaper costs in construction materials? Maybe what you're using is cheaper than what somebody else is using or what's available, but you're putting it in because you're trying to keep the well cheap for your customer? Or using low cost off-the-shelf pumping equipment from Home Depot or from Tractor Supply that's not going to last as long as a Franklin Electric built motor and pump? You know, look at what you're using. Does it really make the best sense for a long-term value? Is it going to last for a long time, or are you building something that's going to require somebody to come out and repair it in a few years? Where sacrifice is made. And this is what I said. Sacrifices are made. Our company makes sacrifices. You know, if something goes wrong on the well, we have to figure out what's the best solution. We try to figure out what's the best solution for us and the owner. You know, what's going to make the most sense in remedying a problem. And a lot of times we have to sacrifice because they don't want to pay the extra, the cost involved to do something that you didn't know. You didn't expect it when you went in to drill the well. No, but you know, there may not be any records that you can use to know everything about what's going on, and you lose circulation or you hit a fracture or a fault. Something happens. You know, did we do the best that we could? Well, normally we do the best that we can with the materials that we have and the money that's available. But is that going to give us that long-term value? You know, a lot of times, like I say, to lower the cost. We want to do things that's going to lower the cost for our customer. We want to do things to win the job. Can you guys go out and name the price that you want to drill a well for, or do you have to be competitive? Most of us have to be competitive, right? I mean, we bid a lot of our jobs. Most of our jobs are municipal type jobs. And them jobs, almost every one of them are either bid or negotiated. And if you negotiate a job, you still have to be very competitive. Or are you hurrying to get to the next job because you're behind? And today, most of us are behind. So we're trying to get done to get to that next job because we have a commitment. We said we'll be there in 30 days. Well, this job's taking 60 to get done. We're trying to hurry up and get to the next job. Did you provide your customer with options to increase the value of their investment? Maybe the owner told you what he wanted, but for a little bit more, you could give him way more, quite a bit more. Did you talk to your customer about, I don't want to use the word upselling because it's not really upselling. It's providing increased value. Did you talk to him about how he could increase the value of his well? This is one of my pet peeves here. And can you hand me that blue book behind you? Most states, when we look at their rules and regs, let me see if I can do it with this one. I can do it with the pointer, I guess. Maybe. Whoops. Now I gotta go back. There. That thing right there. Most states have minimum well standards. Minimum well construction standards is what is on the front page of their rule book, right? I'm looking at the state of Utah. It doesn't say minimum standard. Thankfully, it doesn't say that. Because what are we teaching our kids? What are we teaching the young guys in the industry when we have minimal standards? Do minimum work. We're teaching them that all they have to do is meet that minimum. And nobody's going to say anything. And if we're striving just to meet the minimum, what happens? We're going to fall short somewhere, right? We normally fall short someplace in that job. And if we're just trying to meet the minimum and we fall short, now we're not meeting the minimum. But if we teach them to exceed that minimum, to do better than that, then maybe when they have a shortfall, it's still above and beyond somebody's expectation. So I don't like to see the minimum standards written. Now, there are some places in Utah's book that it talks about the minimum wall thickness, the minimum this and that. It's not very often. Where in some rule books, it's almost every page you find minimum standard, minimum for this, minimum for that. We need to try to do better when we're building our wells instead of saying this is the minimum, because I know firsthand, I used to be the manager for the Rocky Mountains for hydro. And we've had 4 managers, I think, since. And I always tell them, we're going to get in trouble, guys. Well, why are we going to get in trouble? We're meeting the minimum. Because one day we're not going to meet the minimum. And lo and behold, boom, we don't meet it. Sometimes it's because we haven't met the spec. Sometimes it's because we haven't met the rules. We get a fine when we don't meet the rules. We get lower pay when we don't meet the spec. And it's like, well, they can't do that. Yes, they can. It's in the rule. Or we don't follow the permit. Well, in Colorado, I mean, everywhere. If you fail to follow the permit, you're out of spec. And Jim can tell you, plug that well. That well's not in spec, plug it. So then we don't get paid. Luckily, that hasn't happened to us. I mean, we've walked away from wells that did not meet the minimum. We never even told Jim, hey, we're going to try to get this pushed through. If there was a deviation problem or something out of spec, we go in and re-drill that well. Because we want to make sure that we don't try to fall or don't ask to fall short of that minimum. So, we're trying to raise that bar. Everybody should try to raise that bar a little bit. So that's one of my pet peeves is that minimum standard that I see. Colorado's got it. Arizona's got it. New Mexico's got it. Just about everybody has that on their cover sheet. We see it all the time. And we see it in the bid specifications all the time for when we're bidding wells. Meet this minimum standard. I don't like that. Tell me what you expect. Give me your high expectation. Let us strive to get that high expectation, not a minimum. But our culture does revolve around minimal standards, and I'd like to see our culture changed. This is just more of that same thing. More of it, cement grout, surface seals, you know. Our business, it's not an exact business. There's not two wells that we drill. I don't care if they're 50 feet apart. There's not two wells that we drill that are the same. They're not going to drill the same. They're not going to develop the same. They're not going to pump the same. They're not going to give you the same GPM unless your pump only gives you 15 gallons a minute and you got two pumps in the ground. This one might here might give you a 35 if you had a 35 gallon a minute pump, but both of them might give you 15 the way you got them set up. But the two wells are not going to operate the same. Two boreholes are not. Some problems can be predicted. Others, they just happen. And you can ask your driller, you know, why did this take place? It just happened. Well, most of our problems are predictable. Not all of them, but a lot of our problems that we see when we're drilling a well are predictable. This is right down here at Orem. We're drilling for central Utah down here. This has been a few years ago. I believe this is the third or fourth well we drilled for them. Large diameter, 20-inch completions. Screens, there's about 400 foot of screen in these wells. Blank on top, a lot of boulders, very unconsolidated. Kyle got to develop these wells. I think he loved that, developing them, because they developed pretty good, didn't they, Kyle?
The most efficient wells in the west here that I know of.
Yep.
Some have a capacity of 800.
But they were challenging. And we knew going into this project they were going to be challenging because we looked at all the records available. And there was a lot of records available showing how unconsolidated, how much boulders and gravel and everything there was. And I think for that reason we got the job, because I think some people were afraid to bid it. So we get it, and we had a tool pusher, and he was a pretty good tool pusher out there running the rig. But we got ready on this one, I think it was the third or fourth, I can't remember now. We're running our screen in, and he stacked out just shy of hooking up his blank. He was still running, I think, the last jointed screen, and stacked out on a boulder. Remember that?
Yep.
So it's like, okay, what are we going to do? So what he did, lo and behold, I mean, he was already getting chewed out by the office, because he was supposed to run a barrel reamer, because we had to do that on the first well, second well, third well. But because we never had any problems running screen and casing on them, he didn't run the barrel reamer on this one, which would have told us that we had a nice clean hole all the way down, and it was, the barrel reamer was the same size as the screen. So, and it's long, it's almost like running a dummy in a well. He didn't run it. So when he stacked out, we had to use a crane, because the screen and casing's heavier than our rig would set it. So let me see if I can. Does this have a pointer on it too? No, got to use the mouse. So what we have here, there's 200 feet of screen right there. This is not wire wrap. This is Roscoe Moss louver. There's another 200 foot of screen. Actually, this one's, I think, one joint short of 200. This one's got 200 feet. There's 400 foot of screen hanging in the air, because 90% of the time what we would have done, we would have started cutting screen out of the hole, one joint at a time. One joint at a time. But because we had to use a crane to set the screen, the crane already had a hold of it. Let's pull it up. Let's see if we're dragging anything. So he pulled it up, and he was able to get 200 feet out. So he called and got another crane out there to hook on and pull the other 200 foot out. Put the barrel reamer on, went back in, hardly touched anything. Went back in, we ran that, made one cut. So it cost us about 1 day and several $1,000s, but only 1 day's time to do that. You know, so that's thinking. It's kind of the art that goes into well drilling and well construction. I think he did the right thing as a second thing he did, but the first thing, but not run the barrel reamer, that was a mistake. Because we would have ran the barrel reamer, he probably wouldn't have finished any sooner, but he would have still saved crane time. But much of what we do involves both an art and a science. And based on good science, we can understand the need for good groundwater management and proper well design and construction to meet these needs. So it doesn't start with the well driller. It starts with planning. When somebody says, I need a well, it starts clear back there with the planning. You got to look at the science. We got to look at all the records that are available. We got to look and see what Jim's got, and now he's having problems pulling some of it up, some of the records. But no, we have to look at them records. We have to look at everything available to find out what it's going to take to drill in this area. What can we expect out of the water? Or out of the formation? Is it going to give us good water? Or is it not? We don't need to drill a well if we're going to have injurious water. We want water that we can drink in most cases. But how we do that is all part of the art. Because I can build a well 100 different ways. The outcome's not always going to be the same, but I may be able to construct a well 5 or 6 different ways with the same outcome. So we can choose to use the science and all the formation or information available to plan a proper well construction plan, or we can hope to be lucky. In this case, he was hoping to be lucky on that well where he had to pull that casing out, that it would go. It didn't. But a lot of us we hope to be lucky when we start the project. So-and-so says, I need a well over here. So you're hoping to be lucky when you go out there and start drilling a well. You don't even know what the formation's like. You don't know what the ground's like. You don't know what the water quality's like, but yet you're drilling him a well. And in some cases, you do it because you know all the wells in the area are good. Well, I've got a friend in Colorado that owned a huge section of ground, and he was selling 5-acre lots, putting trailers on it. And he had the whole thing almost sold, and he was a well driller. He had the whole thing almost sold, and he sold one guy 2 parcels right in the center. The last 2 parcels. Promised him water for both of them. He went in and drilled, and he got his first dry holes. So we went in, we tried to go ahead and frack to get through it. There was no water there. I said, is it his bad luck or is it yours? He goes, I promised him water. I said, don't ever do that. Don't promise somebody water because you don't know if it's going to be there or not. But we don't want to hope to be lucky. Now, this is us again. This is Hydro Resources down in Texas. I guess we were hoping to be lucky on this because we bid a job down there and it said the job could be constructed either conventional or reverse circulation. 17.5-inch hole. But we could drill it. We had our choice. We had a reverse rig plan to drill this job. And there was more money if that rig went to another job. So they sent that rig to a different job, brought this TH60 air rig in to drill this 17.5-inch hole. How many of you have a TH60? How many of you have a rig comparable to a TH60? What size holes do you drill?
I can do up to 20.
How,
But it won't fit in the mast.
huh?
It won't fit through the table, and it won't fit in the mast.
Yeah. And is it ideal for that big of a hole? Are you drilling with air or are you drilling with mud? Mud? Yeah, it's not ideal. If your formation is right, and you know your formation, if it's more consolidated, yes, I could drill it. Down here, it's a lot of bay fill, a lot of clay. This is Refugio, Texas. They got a big mud pump over here. Whoops, gotta go back. There's a big mud pump off to the left over there, right here, or at least they thought it was a big mud pump. Our project manager thought it was a big mud pump. Whoops, I gotta get this going again. We got air hoses hooked up to everything. We've got a 300 or 500 PSI capacity. They're trying to pump about 650 to 700 PSI. Kept blowing the hose off. They were having all kinds of hell. And they called me up and said, can you go to this job and see what's going on? So I go down. This thing here, is that a mud ring or is that a boot? It's a boot. It's not a mud ring, okay? That thing hadn't come out yet. But they were about 300 and some feet from TD. And they were about, I think, 1,100 foot deep at this point. Deeper than you probably go with your TH60 on them 20-inch holes.
Oh, yeah, I only do them like 50 feet.
Yeah, so a lot deeper. And I get there, and I'm looking at what's coming over the shaker, and it's just mush coming over the shaker. There's no cuttings. He drilled 30 feet, or he drilled about 20 feet down, and I'm trying to catch samples, but all I'm getting is mush. There's no cuttings coming out. And I said, we need to go ahead and pull up, circulate, try to clean this hole up. He goes, no, we got to get TD'd. The hole's swelling on us. Last connection was a little bit tight. We got to go ahead and get this hole TD'd. I said, you're out drilling yourself. He drilled that 20 feet in about 10 minutes. I said, you're out drilling yourself. And, no. Now, he was the project manager. I shouldn't say that. He was he was the project manager. So we're arguing back and forth. The vice president comes out because I called him and I said, we're going to kill somebody because we got a hose blowing off above the driller's head. And it's going to fall and hit somebody and hurt them. Oh, just clamp that thing on better. So he came out, we did that. It fell off again. And he drives off. No sooner than he drives off, this boot came out. And when it came out of the hole, the project manager looked at me and said, we got it. Because I told him we were probably getting a boot. Because we were actually pressuring it more and more and more, which is a good sign that we're not cleaning the hole and we got a boot coming. And he goes, we got it. I'm looking at him going, what do you mean we got it? He goes, well, we got it out of the hole. Now we can get TD'd. So what are we going to TD for? Why are we going to TD this well or this hole if we can't develop it? Why are we going to TD it if we can't produce it? And so him and I, we had a little pissing match out there. I got tired of arguing with him. There was a car sitting there off to the side, over to the right-hand side there. And there was two guys sitting in it with the project engineers representing the owner. And I walked over and I said, would you guys mind if I plug this well, move this rig off, and bring that reverse rig in that we were going to drill it with? Probably can't get here for about 3 weeks, but it's the right way to drill this. And they said, Fred, I didn't think you'd ever ask. So we drilled it reverse, had no issues whatsoever, made all the water that they were looking to make. I mean, it was a problem-free project with the right rig. But we used the wrong rig, and that's part of the art. You got to do all your diligence in figuring out what it's going to take to drill the well right, construct the well right. Part of it's in the planning phase, the well design. Really this job should have never been specified reverse or conventional circulation. It should have been specified reverse, because a 17.5-inch hole down there, you'd have to have a lot of pumps to pump it out fast enough to not damage that formation with all the fines and the clay that was there. But we did get it done. I wasn't a hero with the company because it cost money to do it, but they knew it was the right thing to do, and they said, yeah, let's do it. They were just mad that I'd never got involved in it earlier. But that's expensive art. It's an expensive lesson because somebody didn't do their due diligence bidding the job on our part, and they opted to go ahead and drill it conventional. And it wasn't them two guys' fault. Them two guys worked their butt off to get this job done. So well construction, the processes that we use and the materials which we choose to use all have a direct effect on the value of that asset or that long-term asset. We do have choices when we're drilling wells. From the well design, and again, it starts back at the well design for engineers in the room. Have we designed the well to maximize the yield, to keep the sand out, with material selections, best findings, the latest developed materials, to meet the water quality concerns? Are we using the right materials to meet water quality, or are we using something that, our logger was just talking about running pH. He could tell that water is going to be oxidizing, or if it's going to be corrosive. That's something that's nice to know on these bigger wells, so that you can design your materials so it's not going to be oxidizing. Are we designing it to meet state rules and regulations? And more importantly, are we designing it to be a long-term asset, or are we just designing a well to get water to our customer today? What drilling method? There's that picture. We had the wrong drilling method when we drilled that well down there in Refugio. Is it going to be conventional circulation or reverse circulation? Is it going to be air, or is it going to be water? What step processes are we going to use? Again, there's a ton of different processes that we can use. And you guys probably have the process that works the best in your area. But if you're going into a new area, the processes that you use may not be right for another area. So it'd be nice to know what your competitors, and I don't like to look at them as competitors. I like to look at them as the other associates within our industry. What are they doing? What works best in that area? From drilling to fluid management to development, they're all important. What materials are we using? Are we using PVC, stainless steel? Are we using low alloy with copper bearing pipe? HSLA from Roscoe. And when we use the stainless, there's many different grades of stainless. From 304, 316, duplex. What materials are we using for that to make that a long-term value? And what are we using for gravel pack? Is our gravel pack going to be degrading as we pump water through it, or is it going to be there in 100 years? And that's why we're moving into the glass beads, because we think they're going to last longer, but they're more expensive up front. But over the lifespan of that well, maybe glass beads are going to be cheaper. What operational practices are we using? We need to look at that. And then we also need to look at our scheduled maintenance. Today, everybody's got one of these things that got one on their hip, right? Or in their pocket. What are they called?
Time wasters.
Huh?
Oh,
They're a smartphone, right? Why are they called the smartphone? Because you can almost Google anything, right? You can look up so much stuff. Now, when I started, when you started, I could go around the room. Many of us didn't have a smartphone when we started. We didn't have a telephone when we started. There was no such thing as a mobile phone when we started. Okay? We had to learn out of a book. We had to learn from somebody else. When you got home at night, you called somebody that you thought was smarter than you to ask for advice. Today, people can get on their smartphone in an instant and try to get out of a problem. Or they can call somebody in an instant to get out of a problem. We need to be using them resources for that. We need to be learning. With all the technology we have, there's no reason that we can't learn what's best, what works best. And then we need to be teaching our employees and others in the industry, too, how to use these tools and figure things out. So we don't want to create the same problems that we created 50 years ago when we never had these tools. Because we did a lot of damage. My era did a lot of damage because we didn't know better. We didn't know. There's not an excuse today for not knowing. Okay? There is no excuse for you younger people not to know today. Instead of playing games on your cell phone, get on it and try to learn something. Every day, learn something new about what you're doing in the industry. From these classes, you can come to these. NGWA's got a lot, state's got more, but there's a lot of stuff on your smartphone and your computer that you can learn from as well. I always like to ask, coming from the drilling fluid side of the business, what about your drilling fluids program? How many of you guys use drilling fluids in this room? Just one? Ooh. I wouldn't get very rich working with you guys, would I? No. I'm sure more of you use drilling mud than you think, or drilling fluids than the one I got the hand of. But I like to say, what about your drilling fluids program? Because drilling fluids, your program can either make or break you. It can make or break the efficiency of that well. What drilling fluids products are you using on your wells? Now, these here are 3-pack materials that we use for fluid loss control. And the one on the left is a readily dispersible product. I put it in water, and it readily disperses into the water phase. I don't get fish eyes. I don't get clumps in my drilling fluid. Them clumps that you get when you mix mud, either it's, it could be clay or polymer, them clumps are dry material surrounded by water. And they go back into the formation. They're hard to break down. They're hard to get back out. Okay? So you want to make sure that you use a product that mixes well, have a hopper or some shearing mechanism. When you mix your mud, you don't want to just throw it in and send it down hole, especially if you're in the aquifer, because you don't want raw material getting back into that aquifer. This is what it looked like 5 minutes after it was mixed. Material settled out of the ones that were not readily dispersible. The one on the left that is readily dispersible, the product stayed in solution. We ran it across the screen, and we filtered out a lot of the material that did not go into solution. But a lot of it went to the bottom, too, that we never filtered out. And that filtered out material, what is that? For you, if you're using it as if you're the driller or the owner of the drilling company that's paying for it, it's thrown away money. If it goes across that screen, you just lost the benefit of that material. So you're not getting any value. If it doesn't go across that screen, it's plugging that formation, so now the well owner's not getting any value out of that well. He's losing efficiency. He's losing production capacity out of that well because you didn't have good shearing capability or the right materials for your well. Another reason I ask what drilling fluid products are you using, are they NSF? Anything that you put in the water well should be National Sanitation Foundation approved. Why is that? Why do we want NSF material? To keep from contaminating your fluid and the groundwater. And in the past, before NSF became an issue in 1985, we weren't concerned about contaminating the issue because we didn't even think about what we were putting in the well as being a contaminant unless it was oil or diesel, some chemicals that was hazardous. But we didn't think about lost circulation material being hazardous. But it's not really hazardous, but the lost circulation material, if it's organic, it's got to degrade downhole. It's going to start growing bacteria. And then that degrades the quality of the water. Cottonseed hull, cedar fiber, hay, straw, paper, all them things. We don't want anything that's organic to go into that well. From the polymers to your lost circulation material. Nothing organic should go into our water well. And if it's organic, it won't pass as NSF. But a lot of people are drilling wells that don't require NSF. They don't require National Sanitation Foundation approved products because the regulator in some states says, oh, you're drilling a stock well, you're drilling a dewatering well, you're drilling an oil well, you're drilling something other than a domestic water well or municipal water well, so it's not important what you use. Believe me, I'm going to show you why it is in just a little bit. Approved drilling fluids aid in protecting the groundwater and the construction process. Improper drilling fluids can contaminate the aquifer, They can lower the efficiency and cause premature failure and decommissioning. If we use the raw material, we're not providing a high quality asset to the owner. We're giving him something much less. And we never thought of it in the past. We never thought we were doing anything to degrade that water quality, but we used to be. Now, who says the products don't need to be NSF? In some states, it's our regulators. Jim, every well here requires NSF, doesn't it? I'm trying to think. Every well in the state of Utah, I believe, requires NSF material. More states are actually starting to jump on this, and I don't know if it's because I've been hounding to them or if it was somebody else hounding to them, but a lot of states are starting to come around saying, I don't care what kind of well you're drilling, you need to use NSF material. But they still omit the oil field. The oil field can drill through that water zone with old mud. Nobody says anything because they're going to case that aquifer off. Well, what did they use when they drilled the aquifer? I don't care if they're going to case it. What did they use when they drilled through it? They use mud that's not NSF. They use products that should not be in a water well. And we're seeing more and more lost circulation within our aquifers. They're drilling through that, losing circulation back in it, then they're casing it, and nobody cares, except for Fred. What do they know about the groundwater? What do they know about contaminating our drinking water and the aquifer that it comes from? What do they know that we don't know? Okay? As groundwater professionals, we should know what it takes to protect the aquifer. And even if the rules and regulations don't require NSF materials on a water well, we should be running NSF materials, things that are not going to be degrading that water quality on the wells that we're drilling. So if you're drilling in a neighboring state that doesn't require it, just remember this class that Fred said you ought to be running, or you should be running, NSF material. We look at rules and regs like these right here, 2022, July. Why do we have new regs? I mean, Jim did a good job explaining why we got new regs, because he was kind of forced and mandated to make new regs. But why do we normally come up with new regulations, new rules?
Because somebody was naughty.
Huh?
Because somebody was naughty.
Somebody was naughty. A lot of times that's true. What did I hear over here?
Because you're always trying to improve the process.
You're always trying to improve the process. And we're learning as we go. We're learning from back when the first well was drilled to the wells we're drilling today. We're learning more and more as we go. And so rules are made to protect the groundwater. And I know nobody in this room likes new rules. Even Jim, I bet, don't like to make new rules. But we don't like new rules. Well drillers and pump installers hate new rules, but they're there to protect the groundwater. They're not being written to make your life more difficult, to make you change your equipment. Yes, it might require you to change your equipment because of the annulus size or something, but it's made to protect the groundwater. So you know what it takes to protect the groundwater better than the customers that you're serving, better than most groundwater professionals, even though you're groundwater professionals, better than many regulators. We have a duty as our groundwater professional to convey this knowledge. We need to be teaching. And every one of you in this room, believe it or not, is an educator. Okay? You're out there, you're educating the well owner on what he needs for a pump. You're out there educating the well owner on what he needs for a well. If you understand the rules, if you understand what works best, if you understand the protection that is required to protect that aquifer, you're teaching. You are an educator. And I think everybody in this room is an educator in one way or another. So we have that duty. And maybe drilled in a cow pasture. Most of us that drill have drilled in a cow pasture. Or we've drilled in some kind of a cropland, right? And when we drilled in them, if you're my age and you were out there drilling, you probably did things that you wouldn't do if you were drilling next to the house or drilling a municipal well because it wasn't required. We've talked about this just a little bit ago. Things weren't required for us to drill out in that cow pasture or that cropland. But now that cow pasture is a housing development. And they've got a well that provides water to all these constituents. The cornfield is also becoming up and coming community. It requires water from out in that cropland. If we contaminate that cropland, what's the quality of that asset? What's the quality of the well and the water that it's pulling from? Did we degrade it? Did we hurt it over the last 50 or 100 years? Possibly we did. Because we didn't know better and because it wasn't demanding the same amount of attention as one for municipality or a domestic use. Did the rule makers consider the future needs of the well back when they wrote the specs? Probably not. Did they consider the needs for the aquifer? Probably not. There was plenty of water there originally, but now we're pulling that water table down. The water's becoming more injurious as we pull the water table down because there's higher constituents in the bottom, or I should say more contaminants in the bottom of the aquifer than there is at the top. And then we're also feeding fertilizer and pesticides and bacteria from other wells that we drilled into that same aquifer. Did they consider the future development and demand? Surely not, because I didn't. I mean, we drilled some wells in Colorado, and it took us about 35 minutes from town to get there, or I should say from the last house to get into where we drilled the wells. Today, it takes about an hour to get there, driving through the development, and the wells are right next to houses. But I never, ever thought they would be putting houses back where we were drilling, but they did. So the answer is probably not. They probably never thought about these things. I asked why? Well, because it goes. I mean, there's numerous reasons why we didn't think about it. Today, I think more of us are starting to think about things, but excuses, when they make excuses are like belly buttons. We all got one, right? We don't need excuses. We need to make change. We need to see change. We need to start being more diligent in protecting our groundwater. How can we have a long-term asset if we fail to protect and preserve the aquifer? Well, we can't. If we don't protect it, we're not going to have a long-term asset. But because we're not constructing a domestic or municipal well, a lot of us are looking at cheaper ways to construct and equip it. We shouldn't be looking at a cheaper way just because it's not highly visible. Regulators may not require all wells to be protected, but again, just like I said before, it's our duty to do that. In California, there's a push to convert old wells to drinking water supply. It's not just California. You're probably doing it here in Utah, too. I don't know. You're doing it here. We're doing it in New Mexico. We're doing it in Colorado. But they're trying to take these old irrigation wells and make them municipal because they need more water for the cities. And a lot of the times we can't do it because the well construction didn't meet the criteria for a new well design today. We can't confirm what kind of surface seal we got. We can't confirm what materials was in it, what it was drilled with. There's just a lot of reasons that we can't use a lot of, the majority of them wells that they want to convert. Once we start looking at them, it's like, nope, that well's got to be re-drilled, plug and abandon, move over. And in a lot of cases, you can't do that because now there's houses there. There's no room for the real estate to drill a new well. Again, construction failures, sometimes bacteria. I mean, a lot of these wells, the water quality is just not there. Maybe the farmer was putting something down the well to clean it up that was actually contaminating it rather than cleaning it up. Some of them are just, you're unable to deepen them. They're too small diameter. But we're seeing a lot of premature failures on a lot of them wells. And again, they just don't meet the specifications for a municipal well. Requirements for a water well to be a long-term value, we need to look at development. Development. We need to restore that borehole damage that we caused when we drill a well, and that's if we do the best job that we can. You don't drill a well. Maybe if you're drilling with cable tool, you might not have too much borehole damage. But if you're drilling rotary, I don't care if you're drilling with air, mud, water, you're going to have borehole damage. And we have to develop that borehole damage back out of the well. Guess what the biggest misconception about development is?
How long it should take.
Bingo! Were you in my class before? Time. Drilling a lot of municipal wells, what we see in our bid specs more often than not is you're going to develop for so many hours. It's time. Time is a misconception. Time does not develop wells. Okay, time does not equal development. Anybody disagree with me? Assumptions are that development time is time well spent. Okay, this happened to us out here too, in Utah. We were on a well that we were developing out here. And actually we were gravel packing, and we didn't get enough gravel in because the hole was pretty unstable. The gravels were real unstable. And so we had to gravel pack with thicker fluid than we would normally gravel pack with. So we had more viscosity. Then we didn't get all the gravel in. So said, okay, let's swab, and if we swab all the heavies out, we'll get more gravel. Well, they swabbed for 110 hours. We never got any more gravel in. Less than one bag. And these are super sacks. They're 3,000-pound bags. But we got less than one bag in. Okay? That swabbing is also part of your development process. And spec called for 110 hours of development using a swab tool. Well, we already spent the 110 hours, but we're still 30 bags shy, or about 30 bags shy of gravel pack. And so they call me, because I'm their technical advisor. They call and say, hey, tell me what's going on. Tell me, did the engineer specify the wrong amount of gravel? And that's what you would think if you're 30 super sacks off. So I went through the calculations based on the log and everything. No, the engineer, I think, is right. I mean, we're about 30 bags shy. So I said, we probably need to go ahead and pull the tool out and see what that tool looks like. If you're not getting more gravel, you're just wasting time. So he pulled the tool out of the hole, swab tool, and it's got rubber rings on it for the swabbing, but rubber rings were gone. There was no rubber rings on there. So he had spent 110 hours going up and down with a swab tool that may have lost the rubber elements of the rings, but then 2 or 3, 4 hours of taking it and putting it in the hole.
That wasn't me. It wasn't me.
Kyle's right. It was not Kyle. I wish Kyle would have been on the hole, because I don't think that would have happened. But the problem goes back to educating. Nothing was happening. First thing we should have done was pull it out of the hole and check it. But it even goes back farther than that. The hand that built the swab tool was a new hand on the rig. He went to Tractor Supply, bought him a horse mat because he couldn't find rubbers wide enough for the swab tool. So he bought him a horse mat. He cut the rings out of a horse mat. Well, that's laminated rubber material that he was swabbing with. So I guarantee it probably didn't last 2 or 3 hours. He didn't know, though, because he wasn't taught how to properly build the swab tool. And
Hope it wasn't a used mat.
no, it wasn't a use. He did go to Tractor Supply. He didn't go to the farm down there. Okay. So he swabbed for 110 hours. We probably wasted 105 of that anyway, of that swab time. So time well spent. You can't assume that you're doing something. You've got to know. You've got to develop to get all the drilling fluids out of the well. You've got to develop to get all the cuttings out of the well. You've got to develop to get all the mud out of the well. And when everybody thinks drilling fluids, mud, same thing. No, mud is a combination of the formation and materials you're drilling with. You got to get all that wall cake off the hole. You got to remove that wall cake when you're developing. And you got to get all them fines as close to the wellbore removed as well. So if you don't have any energy, you can't develop. Evacuation of these materials can be influenced by your drilling technique, your drilling fluids program, and your development procedures. So hours of development does not equal a good well development. You need focused, intense energy using multiple proven methods. Our company loves airlifting. Well, most of the wells today, you cannot develop with just airlifting because the water level's getting deeper. You know, we're going farther, and that air bubble coming off the bottom of that hole is very small, very minute. It's coming up, and it doesn't get to any size till it's basically out of the screen zone. It's not really developing the well. But, you know, back in the day, airlifting worked pretty good. Today, it's being less effective all the time. So if that's all you're doing, you know, you ought to incorporate some other method other than just airlifting. I love Kyle's approach to development, using the cable tool rig, swab, surge, and pump at the same time, and measure your results all the time that you're doing that. You know what your baseline is that you started. You know what zones need to be cleaned. Kyle developed the right approach for developing wells. You need total evacuation of all them fluids and that formation fines, not partial. If you only got partial, you've only got a partially developed well. It's not meeting its optimal, efficiency or performance. You're giving the owner something less than what he's desiring. He's desiring the well to be the best well that you can give him to last the longest. But if you don't develop it all the way, that well's going to plug up prematurely. If you develop it all the way, you shouldn't have fines migrating to the wellbore. It should last for a long, long time. You got to have the proper design, tooling, and equipment, which they don't design well development tools at home or at Tractor Supply. Okay, wrong equipment was used. A systematic and measurable approach needs to be done, and that's what Kyle does. He's measuring all the time. He knows at this setting I'm making so many NTUs of sand, so much turbidity at this interval. I'm going to have to go back and rework this interval as he goes to the next one, and next one, and next one. So he's measuring his or gauging his results as he goes. This is a tool I really like. This is a double surge block isolation tool. If you don't have a cable tool rig, this tool works pretty well. And you can find this in Groundwater and Wells, 3rd edition. How many of you have Groundwater and Wells book? Several of you. Chapter 8, if you got the new book, the 3rd edition, I helped write Chapter 8. I'm an author of that book. But this tool is in there. It's multifunctional. It concentrates on the defined interval because it depends on how far you have your packers separated. This little swab rubber here and this one here. You can go 5 feet, you can go 10 feet, you can go 30 feet. But the closer they are together, the more energy you're going to develop within that zone. They can be used to add chemistry. You can pump chemistry out into the formation between them swabs. You can swab and surge fluid into the gravel pack. You can go ahead and pump or airlift. You can do either one with this one. That electric cable is not attached to this well. But this one was airlifting. But you can either airlift or run an electric pump with it. But you should be removing your fines while you're swabbing and surging. And it's going to improve the chances for a good well development. This is it again. This picture's in Groundwater Wells 3rd edition. Basically, it shows how it's built. And again, you can modify it in many different ways, but it's a great tool. Requirements for a well to be a long-term groundwater asset. Again, development. But both the groundwater and the water well's health are compromised when we don't have a good development. That's what I said a little bit ago. If we don't do the best job we can, we're going to shorten the lifespan of that well. And if we shorten the lifespan of that well, we're not providing the best cost to the owner. It's going to cost him more to pump that water from a greater depth because the well is not efficient because it wasn't developed. Another requirement is to be a long-term asset is your well maintenance. You know, just like you, just like me, we go to the doctor for a checkup. The doctor tells you what you need to do, you know, to stay out of the hospital. We need to do the same thing to the wells, but if we do the best job we can building that well, constructing that well, we shouldn't have to go back for a checkup like a sick person does. We shouldn't have to go there and check on it yearly. Now, we can have data collected yearly or monthly or whatever you want to collect that data, but it shouldn't require you to go out and actually physically do something to that well if everything operates efficiently. We get to look at what's it going to cost for that next well. You know, this well, what's an average house well costing today? 20-something? 30-something? I remember when they were less than 10, okay? Now you're up to 30. What's it going to be 10 years from now? You know, we don't know what it's going to cost. And is there going to be room to build another well? Are the rules and regulations going to allow us to put another well in for that landowner or homeowner? You know, we don't know what that's going to be. We don't know what they're going to discover in the next few years, especially with all these emerging contaminants. They may not be able to have another well. Someone once said groundwater is as pure today as it will ever be, but not as pure as it once was. It doesn't matter who said that, and I don't know who said it. I've had several people in the room raise their hands that I said that. You know, it doesn't matter who said it, but that is a very true statement. Our water is not ever going to be as pure as it is today. You know, all the groundwater going back, or all the water that we're putting back in the ground, even though we're treating it, it's not as good quality as what was already there. It may not have the iron, it may not have some of the constituents in it, but it probably has pharmaceuticals or something else that we can't pull out of it, going back into that through our ASR wells. Oops. You know, we need to make certain that as we put water back in, we're doing it responsibly. We also need to do a better job selling the future and not just merely getting by for another day. All right? So I'd like everybody to step up and be able to say, I am a groundwater professional. I'm going to do the best job I can to preserve our groundwater for future generations. It's not just for your kids' lifespan that you got to worry about, or the grandkids' lifespan. What happens 5 generations, 10 generations from now? Are they going to run out of water? You know, I'm praying that these kids that's coming up through colleges today or even through grade school today are smarter than we were. I pray they're smarter than we were, because they're going to have a hard time figuring out the solutions for all the devastations that we've caused them. And you might not think that you contributed to it, but each and every one of us have in some way contributed to the water quality that we're being left with. Remember, your design affects how the well is drilled, built, and operates. Your drilling fluids program affects the well development process. Your development process affects the life of the well and the groundwater that it produces from. And the health of the water well and the groundwater affects the price of the asset. So together, all of us working together, working with our regulators, working with our rule makers, working with our groundwater professionals, other groundwater professionals, working with our well owners, we can make a difference. If we all work together, we can make a difference. And that's what I'm hoping that I get you guys to understand today. We need to work together. We don't look at our other drillers as competitors. We look at them as associates. They got the same goal as you do. They're trying to drill water wells for the need of their customers. You're doing the same thing. And if you know somebody's doing something wrong, you need to speak up. If they're contaminating the aquifer, if somebody else is contaminating the aquifer, we're contaminating the aquifer. Okay? If there's somebody drilling that's an unlicensed well driller and he's doing things wrong, we're doing things wrong because we have a voice. We need to speak up and stop that because we're allowing, when I say we're allowing somebody to contaminate our groundwater. And we can't sit back and let somebody contaminate it. That's the conclusion of my talk. And I know I'm just a little bit early. Actually, I'm 30 minutes early, ain't I? So you guys are going to be getting out of here just a little bit early. Yes?
I try and keep all my holes just as dry as I can, because the mud keeps sticking to my shovel.
Are you drilling less than 2 feet, I hope?
I'm one of the well diggers.
Drilling 2 feet?
And until I get down to the water, strip down to my grease.
No, my grandpa used to be a well digger. And he would dig wells over 100 foot deep, line them wells. And it's like, I try to fathom how he did that. In Oregon, in a lot of places we have high water table, but he'd be pumping the water out underneath of him so he could keep going deeper and deeper and deeper in them wells. And it's amazing what people, even back then, they had a lot of ingenuity as a well digger. But today, not very many people dig wells. Any other questions?
Thanks, Fred.
Thank you, guys.